Stereoisomerism. We already discussed about isomerism. Isomerism are of two types, structural isomerism and stereoisomerism. Here we are discussing about stereoisomerism. What do you mean by stereoisomerism? Stereoisomerism arises due to the difference in the three-dimensional arrangement of atoms in the space. Due to difference in the three-dimensional arrangement, arrangement of atoms in the space, And the branch of chemistry which deals with the stereoisomerism is called as stereochemistry. This stereoisomerism is again divided into two. First one is configurational isomerism. Configurational isomerism. And second one is conformational isomerism. Okay. Here we are talking about configurational isomerism. Conformational isomerism we will discuss in the next session. Okay. So first one is configurational isomerism. What do you mean by configurational isomerism? Before discussing about the configurational isomerism, let us see an important point called stereocenter. Stereocenter. Stereocenter means it's a carbon center, and we know carbon containing four different substituents, four attachment or four valencies for each carbon atom. Okay, if all the four attachments to this carbon atom are different atoms are attached to the carbon atom. Okay, attached to the carbon atom. Such center is called as the stereocenter. So in this case, we can see that if the four attachments are different, CH2, CH3, then CH3. So this is called as the stereocenter or also called as chiral center. And this carbon atom is called as asymmetric center. Okay, asymmetric carbon atom. Okay, this is asymmetric carbon atom and it's denoted by an asterisk sign. Okay, so this is the stereocenter. Now, what is configurational isomerism? Configurational isomerism arises due to the difference in the configuration at the stereocenter. Okay, it arises due to difference in configuration of the atoms. Okay, difference in the configuration of atoms at stereocenter. Okay, so there must be a stereocenter. This configuration isomerism is again divided into two. First one is geometrical isomerism and second one is optical isomerism. Now we are discussing about geometrical isomerism in this class. Optical isomerism we will discuss in the next class. Here we are discussing about geometrical isomers. So what do you mean by geometrical isomerism? Geometrical isomerism. This isomerism arises those compounds containing C double bond C. Okay, compounds containing double bonds. Okay. Also, these double bonds must contain two different atoms attached. Okay, two different atoms are attached to the same carbon atom. Two different atoms are attached to the same carbon atom in the double bond. Okay. This is an important point in the geometrical isomerism. Is such compounds containing the double bond if the atoms, there must be restricted rotation. Okay, so isomerism arises due to the restricted rotation of the different groups attached to the double bond. Okay, to the double bond. Okay, this arises due to the restricted rotation. We know that if there is C double bond C, there must be a restricted rotation, and the different atoms are attached to each carbon atom, there must be a restricted rotation, and due to this restricted rotation, isomers are formed. Such isomers, or this isomerism, is called as the geometrical isomerism. We will discuss with examples. Okay. If the compound C double bond C, okay, and the groups attached are, two groups attached are different, okay, to the same carbon atom, such compounds arises geometrical isomerism. Okay, this isomerism are of two types, cis isomerism and trans isomerism. Okay, cis isomerism and trans isomerism. Cis means on the same side, okay, and trans means on opposite side. So in the case of cis isomers, the groups attached to the carbon atom, okay, the identical groups attached to the carbon atoms, two different carbon atoms, okay, identical groups attached to the two carbon atoms are on the same side, okay. Similarly, in the case of trans, the identical groups attached to the two carbon atoms are on opposite side, okay, opposite side. Take one example for cis. See, in this case, this is 2-butene, okay. So, since the two groups attached on the same side of the carbon atoms, so it is called as cis-2-butene. Here example, CH3, CH3. These two are on the opposite side of the carbon atoms, okay. Such groups are trans, such compounds are trans 2-butene, okay. These are the two important points in the cis and trans isomers. Geometrical isomers are divided into two, cis isomer and trans isomer. Now what about their physical properties? We know that they are similar, but their spatial arrangement are also only different. So the physical properties like melting point, boiling point, the dipole moment, etc. are also different. Okay, they have different physical properties like melting point, then boiling point, because of their difference in the spatial arrangement, dipole moment, okay, solubility, etc. Okay, let us see how this dipole moment differs. See, in the case of cis and trans, CH3, CH3, okay, C double bond C, okay, cis and trans. And in this case we can see that the dipole will be concentrated towards the center. So we can see that both are towards the center. So there will be maximum dipole mu. Mu will be 0.33 D. Okay. So the dipole moment will be maximum in the case of cis isomer. Okay. So now what will be in the case of trans isomer? The net dipole mu. See, towards the center. So these are in the opposite direction. So they will cancel each other. So the net dipole moment will be 0. Okay. So from this we can see that cis isomer is a polar compound and trans isomer is a non-polar compound. Okay. These are the differences between the cis and trans isomers. So this is in the case of C double bond C in alkenes. This isomerism also occurs in the case of C double bond N. C double bond N, and in the case of certain alkanes like cycloalkanes, there also we can see that restricted rotation. In the case of C triple bond N, okay, C triple bond N, we can see that there is restricted rotation. Okay. Also, in the case of alkanes like cycloalkanes are also, we can see that due to the ring structure there is a restricted rotation. So such compounds also shows geometrical isomers. This much about geometrical isomers.